Welcome to the second video about sketching Bodeplots with the simple template. I have here sketched the first order high pass filter with the input terminals, output terminals, and between the terminals we have the capacitor, and over the output we have the resistor. We're taking the output voltage over the resistor. The filter is characterized by its breakpoint frequency defined by this equation, and we know then when it's a first order high pass filter it slopes up toward the breakpoint frequency with plus 20 dB per decade, and it starts at the breakpoint in the phase with 45 degrees. So we can start at this point sketching the Bodeplot. So at higher frequencies than the breakpoint, the capacitor is a short circuit. So then V out will equal V in and we will have no attenuation. So from this point on there is no attenuation, so we at 0 dB here. From the breakpoint and from lower frequencies upwards here, this is the lower frequency part, we will have per decade an upward sloping of 20 dB. And the steps between here is actually 1 decade. So I will have a sloping upwards to this. So this is the sketching of it. So that was the amplitude. The phase, well, we have to put up here 45 degrees, 90 degrees. We have 135 degrees and 180 degrees and 0 degrees here for the high pass filter. At the break frequency we are at 45 degrees. When it's below the break frequency, it will actually behave as an almost open circuit because the capacitor is phase shifting the current, and then on the output we will have the full phase shift. And since the capacitor is sitting in line with the current, we will have a starting phase shift of 90 degrees until we come below 1 decade below the breakpoint. So all signals below the breakpoint frequency will always be phase shifted with plus 90 degrees. From a decade below the breakpoint we go towards 90 degrees to 45 degrees, and a decade over the breakpoint we will have reached 0 degrees. So here the filter has finished phase shifting, and from 1 decade over the breakpoint frequency it actually has 0 degrees phase shift because the capacitor is totally short circuit and we only see V in and a resistor and V out, so there is no phase shift in that when this one is short circuit. So that's the first order high pass filter, and also here first order with a sloping here of plus 20 dB per decade. Now I have indicated here, what about an nth order high pass filter? Well, then we just time n onto this sloping outwards and also n to the phase. That means for a 2n we will have 40 dB per decade, and for a 2 here you will have 90 degrees per decade. That means also a change to the phase shift, because when I have 2 the second order, I will have twice as much phase shift in the break point. So that means I will actually at the break frequency have 90 degrees phase shift. Also at lower frequencies I will have 2 times 90, so I will actually be up on 180 degrees for a second order high pass. And at a decade below the breakpoint frequency it will start phase shifting with now a slope of 90 degrees and continue until it reaches a decade over the breakpoint frequency, when it almost also will end up at 0 degrees. And that was the second order. What about the amplitude of the second order? Let's try to sketch that too. Well, at the breakpoint frequency we will have the 0 dB, even though we know it will be minus 3 dB for first order, and also for an ideal end order we assume we have 0 dB here at this point. But the sloping is now with 40 dB per decade, so I have to consider that I start out here at minus 40 and slope upwards, and the next one will be from 80, minus 80 to minus 40, and from minus 120 to 80. So this is the slope of a second order. And we can see that a second order filter actually attenuate quite a lot more on the lower part of the frequencies. Here I have 60 dBs at a frequency, well, 1, 2, 3 decades lower, and that fits very well with here 3 decades and with 2, so we are up on 60. Yeah, for a second order filter. Why this sketching with these simple templates? Well, since we will use this to sketch out what our filter should be looking like, and we will calculate the filter and then simulate the result afterwards. This is fully sufficient. Thank you for watching.